Okay, so I figured I would keep going with this review. Today, as part of the review, I'm basically going to look at domain and range. So the domain and range of a function I talked about briefly in the last video. Very crudely, it's basically the values that are, so the domain would be the values that are allowed to be inputted into a function, and then the range would be the resultant output due to that input, right? So I might be very much limited to what kind of numbers I'd want to put in my function. And that input might result in limitations to my output. It may not, but it might as well. So just as an example, this is number 9a. I've got y equals 2 x minus 3 squared plus 4. Now I've got an exponent of 2 here, right? We call these second degree polynomials or quadratics. Okay. So we've seen those before. We saw it in the previous example. Okay, so we saw that with I don't know how far back I'd have to go. Oh, here we go. So this is a quadratic equation. It equates to 0 when we solve for the roots, right? Or what we'd later know as the x-intercepts. In terms of domain and range, let's go back to that. So the domain is the set of inputs that I may or may not be allowed to. The domain is the set of inputs that I will be allowed to input into this function. So whatever values I can plug into x. Now, to be honest, like there are only certain things that you're not allowed to do, right? Like for example, the main ones are like you can't take the square root of a negative and you can't divide by 0. Now obviously I don't have that problem here, right? I don't see a square root and I don't see a ratio, right? So the input doesn't affect any of that. So I'm basically like I can plug in anything I want. I could plug in negative 1.1, I could plug in negative a million, I could plug in a million. So what we say is that the domain is basically the set of all real numbers. I could plug in anything that's real. And to understand really the domain of real numbers, you'd have to understand that there are things called complex numbers that have imaginary components. I don't want to really get into that unless the review begs me to do so. So for now, let's just say the domain is a set of all real numbers and just roll with it, right? So here's how you write it formally. So you'd say x belongs to the set of real numbers such that it's the set of real numbers, all real numbers. So that's the domain. Now the range might be different, right? The range is in fact different in this case. The range, if I plug in values for the range, knowing what I know about quadratics, it's not going to be covering all the values of any values out of this set of real numbers. There's going to be a limitation. The question is, what kind of limitation is that? Well, to know that, I have to kind of know quadratics a little bit, right? So in terms of this quadratic, this quadratic equation, we talked about standard form, but there's also something called vertex form of the quadratic. Okay, so vertex form basically tells me, gives me a form such that I know exactly where the vertex is, right? So in this case, I know that the vertex is at 3 in the x and 4 in the y. Okay, so it's somewhere about here, right? On top of that, I know that this function opens up, and the reason why I know that is because this is positive, right? A, the first coefficient in the quadratic, if I were to expand it. So it's going to open this way. What does that tell me about the y values, right? Do I cover anything below this y value? The answer is no. Right? So I can't, right away, the output won't have any y value below y equals to 4. So what I say then is I say the range is y belonging to real numbers such that y is greater than or equal to 4. And that's it. That's the domain and range, right? So it appeared that the domain, basically I could plug in anything I want, but that resulted in limitations to my y values. And that's just because of the properties of quadratic, right? So in the next case, so that was us starting with a function, right? So we started with a function, but we might be able to start with a graph. So they give us this graph here, right? So it's let me redraw it here, just for explanatory purposes. So boom, okay, poorly drawn, but whatever. So this is x equal to 6, right? So basically what they're saying is I can't have any x values above 6. And I know it's above and not 6 or above, because there's a difference, right? So x greater than 6 and x greater than or equal to 6 are totally different because this includes 6. So I can't include that, right? Because if the only way I would include 6 in the answer is if there was a hole there, right? That would tell me that 6 itself is not allowed. But 6 is allowed because there isn't a hole, so keep that in mind just as future guidance. So basically, x greater than 6 is not allowed, okay? So what I would say as the domain of, or the set of allowed values, I would say the following. I would say, okay, domain is still x belonging to real numbers. That means it's a part of the set of real numbers, but what part? Well, the part such that x is less than or equal to 6. So I will allow 6 or less than that, and that's it. Okay. Now, what about the range? Is the range limited? The answer is yes, right? I don't see any curve below the x-axis, right? So there's no y values below 0, right? The x-axis represents y equal to 0. So I'm not allowed any values below 0. So what I would say is I would say y belonging to real numbers such that y is greater than or equal to 0. That's it. So next. Okay, now this next example was a little hard to see. So it's basically a coordinate system, and at x equal to -1, the function, right, starts there, and it goes down to about y equal -2, and then it goes to the left. Think about 4 units from there. So it goes all the way here. So this is the function, boom. Okay, so that's the function. Given that function, sketch on the same grid y, so they want y equals f of 2x. So this is transformations, right? And they want what's called the inverse. Okay, this is not the reciprocal. The reciprocal and the inverse need not be the same thing. Okay, so so let's start with, whoops. Just check that my camera's okay. Okay, so let's just start with the first function, this guy. Okay, now what this 2 does, okay, inside the brackets, inside the parentheses, is it halves all the x values. Okay, so I have to look at all of my x values and basically half them. Okay, so basically this x value is -1. So the new x value is going to be -1/2. What this -1 does is it shifts everything down because it affects the y values. So I would have to shift all of my points down 1 full unit. So I would go to the half of where I am, and then I would shift down 1 unit. So this coordinate right here represents, so these two are identical coordinates, these two guys. It's just they're the transformations of one another. So then I would have that as my first starting point. And then this guy is at what? This guy is at x equal negative 1, 2, 3, 4, 5. So now it's going to be at 2.5. So this, and I'm going to do it in dotted lines, hopefully. Dashed lines. That is basically the first transformation. Now what about the inverse? The inverse basically means switch x and y values. That's it. Just switch. So here my coordinate is it is -1, 0. Okay, so my new point is going to be 0, -1. So that's that guy. Okay, this guy is -1, -2. So my new point is going to be -2, okay, -1. And then my last point is -5, -2. So my new point is going to be -2, okay, -5. 1, 2, 3, 4, 5. So that is the inverse of the function. And that's that. Let me fix the lighting. Okay, next. Determine the inverse of this function. So it's basically a quadratic function. Excuse me, a square root function. F of x equals the square root of x minus 1. Okay, now to do this, so I just explained that it would be switching x and y. To do this analytically, what we would do is we would switch y with x. Okay, so I would call this x, and now I would call this f inverse of x. F inverse of x is the y value of your inverse function, right? And that's what I want to now solve for. Okay, usually what we do in math class is we just say x and then square root y minus 1. I want to go right into saying f inverse because that's what I'm finding. Okay, so now how do I do this? I go I square basically both sides. Okay, that will eliminate this square root. I want to isolate for this guy, so I go x squared equals f inverse of x, okay, minus 1. Now I add both sides by 1, and that will eliminate this term. Okay, whoops. And then I'm left with f inverse of x. So it looks like a quadratic function. Now there's one problem here, right? So when I take the inverse of this function, okay, the original function is this guy. I know that just because I know what these functions generally look like. So if I take the inverse is a mirror about y equals to x. So it will look something like this. So just keep in mind, right, that the function is not going to be a full quadratic, right? A full quadratic means there's this other half. So what I have to do is I have to say x greater than or equal to 0, and that's it. I'm not going to deal with these x values in the negative. I'm not going to deal with them at all. That's not the true inverse of the function. Okay. And they tell you to label the domain in range. So that's where you would label it. So you'd say D equals x belonging to real numbers such that x is greater than or equal to 0. And you would say the range would be y belonging to real numbers such that y is greater than or equal to 1. And that's it. And that's my third part of these review videos. So I will basically continue and work on apparently periodic functions, angles, things like that. Thank you so much, and peace.